Yeah, who wants to see me talk?
Your time zone is wrong.
Hello?
Sorry.
Hello?
Sorry.
Yeah.
Your time zone is wrong.
Oh, yeah, who cares?
No, I want my mind. I want my mind.
You know why it's wrong? Because I missed your talk.
I'm meant to be fixing it.
I missed your talk. Okay, so I better be starting. Just FYI, I haven't practiced this talk because this is a last minute thing. If you were expecting where have all my servers gone, unfortunately, this is a last minute change. Too late to make the program. So I guess he found his servers, so I'm giving a talk instead. And I haven't done this talk in 9 years, so we'll see how it goes. But I did update some slides, so timing might be off. I'll try my best. So this is about PHP architecture, and I'm going to begin this story with two prologues. The first is an old, obscure PHP technique called funky caching. This is also known as error document trick, smarter caching, or Rasmus's trick, but as Derek will tell you, it's not Rasmus's trick, it's actually Stig's trick. And what it is, the idea behind it is you go into the apache.conf file in this old error, you could do it in other configurations, and then you create an error document handler for the 404 that points to a PHP script. That's all the fundamental principle is. Here's what the handler looks like. This is just like a pseudocode. I mean, it's PHP, it just doesn't do anything right now. So when a file doesn't exist, then this thing is called, and it gives the opportunity for PHP to check to see if it needs to return a 404 error page. So something happens and it returns 404 if it doesn't know. But if it can do something, it does that something, it does the rendering or whatever. And then at the very bottom here, it puts it in the file system, right in the web server path. What this means is the next request to the web server goes directly to that resource without starting up this code to generate this data. So that's truly PHP without PHP, and you've actually seen it. That's how PHP.NET has been performant for many, many years without any sort of like mem caching or anything like that. The second paradigm, the second prologue is this concept of paradigms. So to talk about paradigms, I want to bring up this book. This book is called Code Complete, and it was written in the mid-'80s, and it's considered the seminal text of software development, at least in that era. And it was because Microsoft, where the author was working, became dominant during that same era. And even if you're not familiar with it, because it's like an old book, you've probably, if you've ever heard terms like waterfall development or unit testing or things like that, it's probably because someone who informed you about that, or some book you read, the person who wrote that book had read Code Complete, because that's kind of where the first place a lot of these things appeared in print, and a lot of these practices got adopted from it. However, the author, his name is Steve McConnell himself, had just read a book called The Structure of Scientific Revolutions by Thomas Kuhn. And so he became obsessed that everything should be a paradigm. So his paradigm, you can see at the end, is the Practical Handbook of Software Construction. So his paradigm is that software development should be based around the paradigm of construction. And what I'll just tell you is he's full of shit. And that's because there was another seminal text. This one is a decade earlier. It's called The Mythical Man Month. And it was a decade before. In fact, the person who wrote this book was Frederick Brooks Jr. was asked to write like one of the teasers on my copy of Code Complete. And I think Brooks should have been like, this is full of shit. But instead, he's a nice guy or whatever. He maybe didn't read the book, and he just said, oh, it's a great book. What the Mythical Man Month is the term man month or man hours or man years. That term comes from construction. And what Fred Brooks showed is that man month is a myth. That's why it's titled The Mythical Man Month. So let me explain what that means, okay? It's the conclusion, just that adding people to a late project makes it later in software development. So this is just like an example. Let's consider painting a fence, which is kind of like a construction sort of thing. Everything is partitionable, so when I add more people, it takes less time. You can kind of see that. But software development is non-partitionable, so first I have to add some constant time to train that person, and then they have to communicate with each other, and pretty soon, when I start adding people, the time actually goes up, and that gap versus constant time or just having one person working on it is right there, and that's when you add people to a late project makes it later. So if software development was truly construction like Code Complete would tell you, then the man month should work because man months come from construction, but it doesn't. So what paradigm are we? Well, in the 1990s, someone proposed something completely radical, which is that we're engineers, and that the paradigm we should be using is engineering. And what we're doing is, like all engineers, is we're doing a design document. A design document in engineering is something sufficiently complete that it can be built without the supervision of the engineer. That's called our source code. It's just that the builder, being a machine and doing it so fast, creates the illusion that we're the one constructing it instead of the computer doing it for us. And this has tremendous implications, which I won't go into because it's not the purpose of this talk, but you could like look up software development as engineering and read all this sort of stuff. It tells you like the purpose of testing and the purpose of secondary documentation, like in the form of bug trackers and things like that, all as it relates to doing engineering correctly. But instead, because at the time I wrote this talk, I had just been hired instead of as a software engineer, as a software architect at a company called Tagged. And I had this radical idea that maybe we get these titles because they actually mean something. So if I'm a software engineer, I'm an engineer. And if I'm a software architect, I should be an architect. And so I should find my inspiration from architecture, and that's what I did. And that's the paradigm of this talk. That's software architecture with a capital ARCHITECTURE, right? So that ends the prologue. So I'll do this through 3 buildings. The first building I'll talk about that will explain why I brought up funky caching and what architecture really means in software development. The first building I'll talk about is called Falling Water. For those of you who don't know what falling water is, it's in the United States, in Pennsylvania. This is the building. It's designed by Frank Lloyd Wright. It's cantilevered 40 feet above a waterfall. It's one of the most famous buildings in America, certainly the most famous building by Frank Lloyd Wright. In 1991, it was voted the best all-time work of American architecture by the American Institute of Architects. Someone at the conference just mentioned in passing that there's even a Lego set of it. It's over 80 kilometers from the nearest city, but people all over the world, over 1 million people, have traveled to just look at this one building. And one of those people is me. That's me on the right. That's my dad took that photo of me when I was a kid visiting Falling Water. The day it was built, I mentioned Time Magazine wrote about it. And this is because it's an quintessential example of something known as organic architecture by Frank Lloyd Wright. Why and how? Well, let me show you how and why. A first example is a staircase that goes into the stream. It doesn't actually touch the stream, but you can see it connects the house directly to the stream below. The stream and waterfall, although you can't see the waterfall, can be heard throughout the house. The hatchway that is this connection consists of sliding doors, and the bottom step has no support from below. It's actually cantilevered above that and floats above the water. A second example is the windows wrap around the entire building here. And that's so that the building merges with the surrounding greenery from the side. You can't see where the building ends and the greenery begins. Similarly, they use tungsten. Frank Lloyd Wright used tungsten lighting and the glass to complement the fall foliage. So this is the view that actually Frank Lloyd Wright planned when he designed the house in the fall. You can see the lighting and how the building just meshes with its environment behind it. This is a symbol they use in the brochure, so it's a symbol I'll be using when I mention falling water. Panes of glass are caulked directly to each other, and to the steel frame and stone walls to further symbolize the lack of barriers between construction and the surrounding area. Okay. Another example is there's a driveway trellis that has a semicircular cutout. I don't know if you can see it up there. It's literally cut out so the tree goes in the middle. An existing tree goes through the middle of the house. They built like the house around the tree. There's stone floor in the living room. This is the living room. It's quarried from local rocks to keep that locality and environment in there. But this is even more impressive. This rock right here, right there in the foreground, is the original boulder, not disturbed from its original position. He literally designed around that, and that's because the boulder was the favorite boulder of the Kaufman family that had the house built when they would visit before the house was even designed. That just gives you an idea of the extent that Frank Lloyd Wright went to when he had the house built and the environment he considered. From details like these to the whole view taken at once, you get the feeling that in spite of very sharp horizontal and vertical lines of the building, the whole of the building lives in harmony with its environment instead of, quote, lording above it in an isolated spot as a man-made imposition. And this is why this building is recognized as a natural wonder, practically. What Frank Lloyd Wright did is he surveyed the grounds before building it and built it according to his concept of organic architecture. You may have heard the term form follows function. Frank Lloyd Wright believed that organic architecture meant that form and function are one. He also had terminology like it should be democratic, which means design should accommodate needs. It should be plastic, meaning physical elements should remove those barriers. I mean, think like of the glass panes and the noise of the water being throughout the house. Continuity means an element should be a part of nature, whether that's the rock that forms the living room or the tree going through the middle of the driveway. How does funky caching represent this? Well, every time you visit php.net, you're using it. When you type php.net/stir, as a cynic would say, because PHP is so damn slow to he basically would say, well, that's because you don't know if it's, needle haystack or haystack needle. I still don't know because half of the functions are the other way. So I need to do needle haystack, but php.net answers that super quickly, even though PHP may be relatively, especially back then, very slow to execute. And that's because it's using funky caching to actually serve you static pages that are dynamically generated. And so even if PHP is slow to execute, you could argue that that no web language is going to outperform a static server. So this trades off speed of execution with speed and ease of development. It's fundamental to the design of PHP, and funky caching follows that thing. So it's truly in harmony with its environment. For example, I mentioned PHP usually needs something to support it. It doesn't have its own server. In this case, Apache, it could be Nginx or whatever. It's taking advantage of a feature built into that server. Performance is paramount for these sort of things, especially back then. And we didn't have Memcache or Redis. So the file system was a lot faster than everything being in the database. So solving this sort of demand for a large customer-centric problem means that it was in harmony with PHP itself. In fact, would this solution even exist in a relatively slow database world where everything was done from the database? And consumers didn't demand millisecond response times. And the language itself, PHP, has gotten more complicated. This is like an old architecture I did 10 years ago. Typically, it's like that's the original way, PHP and DB, but now we add a Memcache that we use and a file system. There are just a lot of things in the PHP system that we're connecting to, and PHP sits as a component inside that system. And that's really PHP's success as a language, whether you talk to Rasmus, or you saw Rasmus talk recently, just 2 hours ago, or just in general. It's been its success. So what is this environment and architectural philosophy of PHP? I'll just distill it into, I think, 3 concepts. The first concept is PHP is cheap. And a quote I use to emphasize this is from Philip Greenspun, who isn't a PHP developer. I think he's like a C coder or something. And he wrote, a project done in Java will cost 5 times as much and take twice as long and be harder to maintain than a project done in a scripting language such as PHP or Perl. But I just don't mean cheap in terms of that. I also mean in terms of developer time and resources. It's a very easy way to lift a lot in terms of your time. Another example, another feature of PHP is it's very scalable. It's scalable. Here's what Harry Fuchs says, but at the bottom you should just say, PHP delegates all the hard stuff to other systems. It's scalable because of what people call a shared nothing architecture. It doesn't give you any rope to hang yourself. You can't do much in PHP. You always have to bind to something that does the work for you, and that's how you have scalability built in. When I first coded my first web-specific language, it was not, besides Perl, because Perl's not web-specific, it was ASP, which I guess is now like ASP.NET, and it had application variables, which don't scale across multiple servers. So it gave you a feature that literally hung yourself if you used it. PHP doesn't give you any of those. The third thing is PHP is eminently pragmatic. This is a Rasmus quote from years ago. PHP is not about purity and CS principles or architecture. It's about solving the ugly web problem with an admittedly ugly but extremely functional and convenient solution. If you're looking for purity, you are in the wrong boat. Get out now before you get hit by a wet cat. He hasn't changed at all. 2 years, just 2 hours ago, he basically said the same thing. He's like, I designed PHP to integrate with C as a templating thing. I didn't think anyone would be doing this stuff in PHP. But its success has been because it solves that hard web problem really easily. It may be hard to do, but PHP has like database connectors built in. It's just so convenient. It's ugly, but it's very functional and convenient. And could you imagine anything else being designed, but an ugly language, being designed to fix or deal with an ugly problem? That's really being in harmony with this environment. So you might say, well, I'm not a PHP developer, or I'm using a framework. And the framework, I'll pretend, even if it's written in PHP, will make PHP so elegant, like Laravel people might say that. I don't know. But, they're like, I got rid of all the nastiness of PHP and it's now beautiful. It's convention over configuration or something like that. Well, the answer is the designs of those things, whether it's a framework or a different language, they change the environment. And so what you do may change because your environment, what you're building in has changed. But like funky caching, your architecture should be in harmony of it. So let's talk about the second concept, which is second example, which is what happens when it's not in harmony. This is an example of what I would call architectural design hubris. What is Bellafield Towers? Well, no one knows because it's such a shitty piece of architecture. So I'll tell you what it is. It's something personal to me. This is where my mom worked until the day she died, but this is me. You can imagine me as a kid. This is the University of Pittsburgh, and to the left is Building Row Hall where she worked. Okay? 1 block away on the corner of 5th Avenue in Bellafield is this very strange thing. Okay? So I just took a bunch of screenshots in Google Maps 10 years ago, so it's probably better now, but the bus is moving backwards, whatever. There it is. Let's look up, shall we? If you were in Pittsburgh since the late 1980s, you wouldn't understand how the hell this could have been. Like, look at it. It's this like old tower and this like hyper modern rounded rectangle sitting next to it, which by the way is called Bellafield Towers. The rounded rectangle part, not the actual thing. That's just a belfry tower. Well, what happened is There was a church there. It's one of the oldest churches in Pittsburgh. It was called Bellafield Church, and it was built in the 1880s, and it was moved 2 blocks away down Fifth Avenue. And the building was sold a century later, in the late 80s, early 90s, to developers who were trying to exploit it to build something to support the Pittsburgh Supercomputing Center, which you don't know is right across the street from this building. But there was a movement in the city by a bunch of people to save the old tower, so they got it marked as a landmark. So the developer demolished everything but the tower, because only the tower is the landmark, and then built this ironically named Bellafield Towers around it. And let's look at the environment this hyper-modern building sits in. It's not just this tower. I want you to understand, Pittsburgh is not like that at all. This is the current Bellafield Church, the one that's 2 blocks away. And it's an example of the city architecture, which this tower is one of them. The city architecture is known as Gothic Romanesque, and it's all throughout the city of Pittsburgh, where I grew up. This is the examples of other city towers. This is the courthouse and jail in the downtown region, which is, all these neighborhoods are really close together. Across all of the ones I'll talk about is less than 2 miles. The university is in Oakland neighborhood, and then the other neighborhood over is Shadyside. That's a house in Shadyside, same architecture. On the top right is a local, they were a Korean Presbyterian church, they're now just a Korean non-denominational church. In the same neighborhood as Shadyside. You see the same architecture. By the way, just as a side story, my mom was a Catholic, and my dad was nominally a Presbyterian, but my mom called him a Seventh-day absentist. Every seventh day he was golfing. And I want to add that I actually went to a different Presbyterian church, which I didn't pull up. It's in Squirrel Hill. At the time it was in Squirrel Hill. It was next door. It's also a Korean church. It's in the neighborhoods called Squirrel Hill, which is just this same region. And I used to joke back then that if you had 2 Korean families, you'll end up with 2 Korean churches, because someone will get into an argument. That's actually why there are 2 Presbyterian churches practically next to each other. They're like less than a mile away from each other. It's because, I mean, there are not that many Koreans in Pittsburgh, so you can imagine, like, it's literally someone did not like the sermon the pastor gave, and they formed another church. And that's why they were, and actually we shared this with the 6th congregation of the church I was in. And that's the same church that Mr. Rogers was ordained. So I actually saw Mr. Rogers, like, he would come, stay late sometimes and like do the puppets and everything. It was amazing. He's exactly like he is on television. That neighborhood, Squirrel Hill, where that church is a Jewish neighborhood. 1 block away from that is the Tree of Life Synagogue, which is where that massacre occurred last year. And geographically, everything I've described is within a 2-mile radius. Just to give you a huge example, just if you look the other way from Row Hall, from my mom's office, you would have seen this. This is known as the Tower of Learning. It is also Gothic Romanesque. It's so obvious, the same architecture. And it's often called the tallest schoolhouse in the Western Hemisphere. It's practically within spitting distance of Bellafield Towers. Almost literally spitting distance, because the building is 42 stories. Small side story, a few years back, my brother bought me this poster because he knew I was so obsessed with the Tower of Learning as a child, because my mom worked there. I used to say, my mommy works there. She actually worked 2 doors over, but whatever. And so my brother bought this poster. Those are students at the top of the Cathedral of Learning watching a baseball game. What my brother didn't know, even though he's a big sports buff, is what game they were watching when that photo was taken. They were watching this game, which is, the photo is capturing one of the most iconic moments in all of baseball. It's the only walk-off home run in a Game 7 of a World Series. Bill Mazeroski of the Pittsburgh Pirates in 1960 hit a home run in the 9th inning and beat the New York Yankees in Game 7. The Yankees were unbeatable in that era. That building right there, that's behind the home run fence. This stadium doesn't exist anymore. It's Forbes Field. What is that building? That building is Carnegie Library. Another example. It's the main city library. Another example of the same architecture. So why is Bellafield Tower so ugly? Well, that's because instead of when faced with this gorgeous 100-year-old example of the area's architecture, instead of working with the environment, they, like Frank Lloyd Wright would have, the developer didn't give a crap, and he just cut the whole thing and built this curved, rounded rectangle. And I hate rounded rectangles. I used to say Ruby on Rails is like a rounded rectangle. And I'm not a fan of, having had to code that professionally for a few years, I'm not a fan of Ruby on Rails. Never have been. I'm more a fan of the ball of nails that is PHP. This ugly thing that sticks to shit. Well, I grew up watching the Bellafield Towers thing happen, and it became a life lesson in architectural design hubris. But you're like, well, in software development, it's software. There is no such thing as design hubris. And, I'm a developer. I can make software conform to my needs. Really. Aren't you really trying to lord over the environment? Well, but it's all man-made because it's software. There is no environment. But that's not true. The language you're using, the infrastructure, your team, everything is all your environment. Whatever choices were there when you joined, that's your environment. And you're trying to build whatever you are inside that environment and be harmonious with it. Sometimes it can be a literal environment. At Tagged, we had cubes. And when we grew too big, I advocated we switch to an open office, which I only did after we just grew too big for it. This is like 10 or 11 years ago. And the reason why is I grew up in an open office. Most of my companies were in open office. And so when I sneak into places and eat lunch, I actually saw both cubes and open offices. And I noticed it was crazy. Like, for instance, at Yahoo, they use cubes. And at Flickr, which Yahoo bought out, they were used to open offices. So when Flickr got absorbed by Yahoo, their offices had cubes, but the cubes only went to waist high. So it's like, yes, they're cubes, but they preferred that open office, so they did that compromise. But cubes are I thought, from what I had seen, that cubes were only valuable for salespeople and QA and people who were on the phone all the time. And what I found out when we outgrew it is I didn't anticipate everything. We had an engineer who I knew was terrible, but I was an architect, so I didn't hire the person, so I don't care. But I knew he was terrible, and I didn't deal with it. Now, when he was in a cube, it was not a problem, but it was just his problem. But when we moved him to an open office, he messed up 3 people right in his section, because they saw his lack of work and they similarly lowered their programming to his level. So that is like all patterns, all choices, they come with consequences. A consequence in this case I didn't anticipate. I almost lost 4 engineers instead of 1. So also we had a waterfall process. This is another example. And we used to release, when I joined, I was releasing 2006-08. That means they did 8 releases. I joined in 2007. So that means they only did 7 releases in all of 2006 as a web company. A social network, by the way. That's crazy. When I left, we were releasing every day. Now people release continuously. It's obvious, right? But that's an example of gradually getting to that, because I was there for 2.5 years. By understanding the environment. So when I joined, they were at 20 million users. That's pretty sizable, but only doing 20 million page views per day. The site was crashing, and I can talk about how I did things in architecturally to scale it, but just hand wave and say that I considered the environment and I built my solutions within that environment. So by the time I left 2 years later, we were at 80 million users, 250 million pages per day. That's 7 billion monthlies. We were the 3rd largest social network in the United States according to nearly every metric. And 40% of it was one app I came up with just on the fly because we didn't have much user activity. Basically, I'd show you a picture of a person on the site, and you'd say if you want to meet them or not. And if there was a match, we'd match you, right? But this was before there was an iPhone, so it was a long time ago. So all these kind of solutions within that environment. So as a counterpoint, I'll give you an example of a design hubris, which is, I think, Friendster. The company I worked at before Tagged was Plaxo, and I was actually interviewed at both Friendster and Plaxo. Friendster, for those who don't know, was MySpace before MySpace, which was Facebook before Facebook. Okay, it was the hottest thing in the universe, and I was interviewed because they had just gotten venture money and they were switching from Java to PHP because the vice president of engineering was convinced that their problems lied with the fact that they were using Java. What happened was, a year later when I was working at Plaxo, I went to OSCON, and my high school friend from physics was actually working for Yahoo. So he was at OSCON, and I told him to go to all the Perl talks because I couldn't attend them. And I heard Perl was the Perl speakers were amazing. And in it, he went to a talk by some kid who was working on a blog called LiveJournal, and in it, on the slides, he mentioned something called Memcache, but I didn't know that. All I knew was, here are the slides, Terry. Here's a link to the slides because you couldn't go. And I sent it to my coworkers at Plaxo, and they found that slide saying use Memcache, and it was fixing a problem Plaxo was running to. All sites in that era were running to the same problem. The sites weren't fast enough, and Memcache was the solution to that. And it was buried in some kid's LiveJournal, how he built LiveJournal, Brad Fitzpatrick, how he built LiveJournal talk. And because of that, Plaxo used it, and they got bought out by Comcast for $150 million. And I don't remember whatever happened to Friendster, even though they had far more money. And the reason why is because the site was super slow, because they thought the problem was PHP and the language, and not what was really going on. They had a caching issue. They were still reading from the database. Like building falling water without getting an adequate survey done, every day people make this mistake of not looking before acting. They try to make PHP look like Java with dollar signs or something like that, instead of understanding the environment that PHP gives you. They expect environment to conform to their reality so that they can lord over it like some man-made imposition. Please don't do that. That's bad architecture. So the last part is Golden Gate Bridge. I long since moved from Pennsylvania to the Bay Area. In 2007, around the time this story happens, I moved from South Bay to San Francisco. And my weekly run back then was across the Golden Gate Bridge. And now I cross it on my weekend bike rides, every weekend. This is a photo I actually took on my weekly run. There's another bridge that's equally big, built the same 1 year later. It's in the same city. It's a beautiful bridge also. It's longer and it actually has more utility. Emperor Norton once proposed that they build this bridge, the Bay Bridge, that crosses the thing. But no one considers this a landmark, even though, or an icon. Yet you see the Golden Gate Bridge, you associate it not just with San Francisco, but the entire state. These are more photos I took. This photo from Angel Island. Just to give you an idea of how this bridge fits in its environment. This is from Angel Island. This is from the Marin side of the Golden Gate Bridge. I took these photos over 10 years ago. Same problem, but a different pattern. Instead of using cantilevers like falling water to hold things up, it's using suspension. So instead of holding things up from below, it's holding it above using suspension. In fact, it's a pure suspension design. And I might mention that, I'm going to turn that off. I might mention that the original design of the Golden Gate Bridge was a hybrid cantilever suspension structure, but it was replaced with a pure suspension design because the former was deemed too ugly. And it was the first pure suspension design of this length ever attempted. And so many bridges are sister bridges of it because of its beauty, right? Because of what it represents. There's an Art Deco influence. You can see this is a picture I took of the towers. Of the bridge tower, the lighting, the pedestrian walkway. That decorative influence was very influential in that era, and it adds to the beauty. It actually fits within its environment. The bridge was painted in a specially formulated anti-rust paint called International Orange, on demand from the locals. The War Department, because it was built during the Great Depression, wanted to be built in black and yellow, so that it could be seen by the passing ships because it's so foggy in San Francisco. But the locals demanded it be built this in this orange. And can you imagine this in black and yellow? This is another photo I took. It evokes the hills of Marin. It evokes the setting sun. It's really a gateway, the Golden Gate. And it's still natural and visible enough to be safe. this rust-colored suspension-only Art Deco structure, it became this icon. And every week I cross this bridge, and I'm thankful to live in such a beautiful city. So how's that related? Well, I'll talk about something called design patterns. Design patterns, you know from the Gang of Four book, but it actually comes, if you read the first few pages of Gang of Four book, they're quoting this definition of design patterns from architecture. Literally, this book of architecture, Christopher Alexander's Timeless Way of Building. And this is the actual definition of design patterns that you see in the Gang of Four book. Okay, it's literally from architecture. Isn't that crazy? And it's a typical definition. It says that a pattern is a solution to a problem that occurs over and over in our environment, but never the same way twice, and it's defined by context. Great patterns, whether that's a cantilever in the case of falling water, or a suspension in the case of a Golden Gate Bridge, is which pattern I use is determined by the environment. Imagine falling water with a suspension design. It would look terrible. It contrasts with the natural beauty of that area. Whereas the opposite would be true if it were a hybrid suspension cantilever design in that. They're wholly determined by the environment it's in. What design pattern you use should always be determined not by what's your favorite one today, but by the context of the problem. What best handles that. A cantilever is wholly appropriate for the floating look of falling water, but it is the reverse for Golden Gate. When choosing, those, by the way, were pictures of me in the previous slide, in case you didn't gather that. When choosing between a singleton or a global variable, which pattern you use is not absolute, but it's determined by the environment. Let's talk about funky caching and my use of it. This over and over again, but never the same way twice. This is his definition in Rasmus's talk that popularized it. This is at my previous company as in before tagged at Plaxo. I built e-cards, and I needed to store all of these images in a database. I had to do that because Plaxo was all written in C++, and I was actually writing C++ templates, and I built this in PHP. So the only way I could communicate is through JavaScript, through the client, or through the database. Those were the only two options. So I actually stored it on the database. But using funky caching, I dealt with the fact that the database is slow by caching these images on the disk when it was done. Similarly, this is how eCards got built. It was very impressive 13 years ago. Just trust me. I also built a JSS CSS compiler at Tagged. Nowadays, we just use Node.js to just compile something using Webpack, but I had to build all that myself because there were no compilers. We imported 1/64 of our production data into the staging environment, and this is what you would see, just all these broken images. So I use funky caching as a proxy to download those images and save from prod, so that QA, when they did testing, could operate on a real-looking environment. This is actually the code for that funky caching piece. And you see the same three things. This builds the image, right? This checks to see what the URL is, checks to see what I need to build, right? And then it calls the thing to build it. And if it's not there, it returns a bad 404. And then here, it saves it to the file system. Pretty easy. Right? Oh, right there it saves it to the file system. The curl is where I proxy it. Sorry about that. Same concepts as Stig, or a Stig trick. Okay? I must have gone back. So in San Francisco, what I do is I look around me. I live in a city where I can look to that architecture for inspiration. That's my city. You can use your city. Just recall these 4 principles of organic architecture from Frank Lloyd Wright. The first is organic, which means form does not follow function. They're one. Let's think beyond funky caching. It's a sleight of hand trick. It's actually a design pattern. And the design pattern it really is called cache aside. And there it is. The trick is you see the first part, the second part of the caching, except instead of a data store, we're doing work. But it's the same concept. And the third part is on the way back, we save to cache, right? But the trick, the sleight of hand trick, is that it spans multiple systems. It spans both Apache and PHP. One part is the web server, the other part is PHP. With a little bit of creativity, this applies to not just that, but every modern application. Instead of dynamic page generation, we could use web query. Instead of caching the file system, the cache could be Memcache or Redis. Instead of bypassing the app server, we could bypass the entire website, whether that's using a reverse proxy or a CDN. That's literally the same pattern over again, right? Whether to use it and how is always determined by your environment, right? Now we have fast memory, so our site caching wouldn't use the file system as an example. So that covers the funky caching symbol. So just the other term, democratic, I'll use Golden Gate Bridge. Design should accommodate needs is what democratic means. So I'll tell you, I said Ruby's on Rails. I shit on Ruby all the time, right? So let me build a bridge to the Ruby. Let me throw them a bone. Let's build them a bridge that shows that I'm going to talk about Mod Ruby and AWS. Mod Ruby shares, that's the old version of Ruby that worked inside of Apache. It shares the application variable space, which meant that you couldn't use Ruby on Rails in a shared environment, which was all the environments then that weren't co-located. So your choice back then, if you did Ruby, was you have to immediately graduate to a $1,500 a month share, co-located environment. You couldn't do it in a shared environment like PHP. But in 2006, Amazon introduced EC2 to AWS, which meant instead of having to go $1,500 a month, Ruby developers could now pay 5 cents an hour, right? And they adopted in droves. PHP developers, they didn't need that. They had shared hosting. They paid less than $30 a month for like GoDaddy and less than $15 a month for DreamHost. So they didn't need this. So they didn't adopt it, these virtual environments like EC2, but Ruby did. And they adopted it in droves, and they gave us modern DevOps. They gave us Puppet and Chef for configuration management. They were like, oh, there's this new tool called Git that's way better than Subversion. Let's put it on the web like SourceForge, and they gave us GitHub. They were like, oh, now that I have my code in GitHub, why do I need to configure it? Why can't I just point it to my GitHub instance and have it go live? So they wrote Heroku and EngineYard, which you know maybe as Elastic Beanstalk, which is like basically a clone of those products. For AWS. They gave us Vagrant because they wanted to do the same thing that they did on live production on VirtualBox. Okay? All these things, we owe them. And through that democracy, Ruby and cloud computing was designed to accommodate their needs because of the inefficiencies in Mod Ruby. And through that, they represent that democratic thing, that design should accommodate needs. Ruby's success is related to that democratization. In the PHP world, we can adopt this because PHP is scalable, it shares nothing. So we can just use that stuff. We use those tools. Maybe you use Puppet or Chef or GitHub or whatever. Other worlds like Python and Go, they're not used to that shared nothing. So they adopt and extend. So they give us things like Kubernetes or Ansible or Docker. So that covers two of the concepts. The third is plasticity, and it means physical elements should remove barriers. Let's talk about JavaScript a bit. JavaScript started out as a marketing portmanteau between LiveScript, which they were developing, and the popularity of Java from Sun. So they asked Sun to just, if they could use the name Java and rename it JavaScript. That's not an auspicious beginning for a language, but they did it because there was a feature in hypertext that was implemented by Bill Atkinson called HyperCard that allowed you to do events on mouse over or whatever. So they just wanted to add enough to HTML to add things like on mouse over events. They didn't really care that the language sucked ass. Okay, but JavaScript ended up hitting the big time and it became really powerful. Like it replaced so many things. So they're like, we're coding these rich libraries like jQuery underscores and Backbone. They started building these complex things on such a simplistic language. And they were running into all these issues like package management and installing, so they invented NPM, right? And then they were like, well, now we have this compiler. We have this thing that can install. Why don't we add another thing called Webpack that can actually compile these things so that it can turn it into a single file because we don't want to link 50 files in JavaScript. Again, they hit that problem. So then they introduced things like CoffeeScript and TypeScript and other things that transpile the thing because they have Webpack now. And then, like Facebook's mentality, we'll skip that because here's what I'm going to talk about. That is plasticity, and PHP can take advantage of that. PHP is practical, and Facebook's engineers are PHP engineers, so they're very practical. Say they design React.js to express that practicality, they realized they needed more performance than most JavaScript frameworks, so they introduced VDOM. And they're like, well, we have Webpack. Why are we writing in normal JavaScript? Let's write in ECMAScript 6 and have the Webpack transpile it. So we can write it in a language that's more conformant for modern development. Even PHP's PHP mentality can have this shows this plasticity influence. Remember, PHP is cheap. Well, it's like NPM's great. Let's copy it. And that's how we got Composer. The last... all things that remove barriers are plasticity, and these are examples of removing barriers, all influenced by the JavaScript world. The last thing is continuity. Rounded Rex, you're like, you were nice to, you were harshing on Ruby, and now Ruby on Rails, and now you're nice to it. Like, throw rounded rectangles a bone. So I'll do it with continuity. An element should be part of nature, is what continuity means. So this story is about a guy I met 4 years ago, or 3 years ago at Computer History Museum. He's called Bill Atkinson. And to me, he's like, I idolize the dude. And the reason why, which you probably don't know, is he wrote the original graphics toolbox for the Macintosh. He also wrote Mac Paint, and he also wrote HyperCard. So he, like, doing that is why we have the web today, because people saw this hypertext and they wanted to put it on the internet, and that's why we have HTML. But this story is about from folklore.org, and it's that Bill Atkinson worked mostly from home, and he was working on the toolbox, and he invented this oval routine. He designed this way of doing ovals. And he was showing it off to everyone on the Mac team, and they were really impressed. And Steve Jobs, the late Steve Jobs, but at the time he was there in a total a-hole, he's like, why doesn't it do rounded rectangles? And he's like, who wants to do rounded rectangles? That's stupid, and plus it'd be impossible. So, but Jobs is like, circles and ovals are cool, but rounded drawing, he literally said, but how about drawing rectangles with rounded corners? Can we do that? And he's like, no way. And Steve Jobs, because he was an a-hole back then, he was probably an a-hole his entire life, but he was especially an a-hole back then because this is before he learned his life lessons. He said, what are you talking about? Rounded rects are everywhere. And he basically, rounded rectangles are everywhere, or rather rectangles with rounded corners, because he wasn't an engineer. And so he literally pulled Bill Atkinson's up, and he like dragged him up, and he said, look, there's a rounded rect here. Look, there's one right there. There's one on the speaker there. And he literally just dragged him through the office and had him do it. And then he took him outside, and he was pointing out all the rounded rectangles. And finally, he passed a no parking sign with rounded corners. And he's like, Atkinson's like, okay, I give up. I'll see what I can do. And the next day, he came back to the thing, and he had this big smile on his face. He now got his demo showing rounded rectangles really fast, and this is on a small little ROM. And he added this code to the Lisa thing. He called it rounded recs, and rounded recs work their way into everything. Every user interface element we know uses rounded rectangles, and we have that to thank. So rounded recs can be beautiful. In fact, that's the part I like about Ruby on Rails. It looks pretty. It just doesn't do much. So what I'm trying to say is look around you for inspiration. Steve Jobs forced Bill Atkinson to look around himself for inspiration and gave us this amazing user interface element. I hope this tour of software development in a different way helps you find solutions and using the right solutions that work with this. We can never build an amazing city by ourselves like San Francisco or the city you live in or Montreal. But together, when we apply these patterns and these principles and use the patterns to do these principles to work harmoniously in our environment, we do create these amazing structures in the open source world. They're as harmonious and beautiful as a city, the city I live or the city you live. Thank you so much. I'm sorry I'm a minute over. I'm on all the social networks. You can come up to me afterward. I have some cards. Just say we met. This is a link to the slides if you want them. Just say we met at Confoo, and I'll friend you back, definitely.